Welcome to Magicore, the automated core documentation service. Let me show you how to process a borehole in just a couple of minutes. After entering your API key and signing in, we start by uploading the borehole data. You can either select individual photos or upload a zip archive. I'll upload an archive. It's much more convenient when dealing with a large number of images. The system automatically extracts depth values from file names and links each photo to the corresponding depth. This saves a huge amount of time. There's no need to input data manually. We check that everything has been recognized correctly and confirm. Now, let's move on to the processing settings. Here you can adjust the fracture classification threshold. This affects the sensitivity of fracture origin detection. You can also enable models for calculating the alpha and beta angles, which define the spatial orientation of fractures. Angle calculation is computationally intensive, so it's turned off by default. Enable it only if you really need that data for your analysis. For basic documentation, the standard settings are perfectly fine. Alright, let's start processing. The system now recalculates rating parameters across intervals. Intervals can be generated in different ways. By default, the system creates them automatically from 0.3 to 3 meters, optimizing the segmentation based on the variation coefficient of fracture density. But you can also define your own intervals. You can even set larger geological intervals, say 30-50 meters. The system will automatically split them into smaller geomechanical subintervals. Now, let's look at the main result. We download the Excel documentation. On the first sheet, you'll find intervals, the RQD rating for each, and the number of fractures per meter. The second sheet lists each fracture separately, its depth, origin, natural or induced, and the alpha angle. Fracture zones are highlighted separately, as well as disking zones. When under high stress, the core begins to split into disks. These intervals are important for analysis. The system also identifies sections best suited for sampling, for laboratory physical and mechanical testing. Next, let's visualize the results directly on the original images. Choose what you want to display, enable visualization, and here are your annotated images. You can download the archive or view the preview right in your browser. See, the core segments are marked, fractures are detected, ellipses show angle estimation, and crushed zones are highlighted. Each fracture is color-coded depending on its origin. And finally, a very useful feature for working with GIS systems. You can merge core sections into continuous fragments, for example, 3 meters each. In GIS, it's much easier to work with continuous depth-linked fragments rather than separate core boxes. Preview or download the archive. Here are the 3-meter segments, each labeled with depth information. Inside the archive, you'll also find a CSV file for easy GIS integration, with the borehole name, image name, and from to depths based on your chosen step. That's it, the full cycle from upload to complete documentation. What used to take 2 to 4 hours now takes just a few minutes.